It's another interesting video with Professor Ekpete on the electromagnetic spectrum. Last time I promised that I'll be talking on the electromagnetic spectrum. Don't fail to subscribe, like, comment, and share this video. At the end of this lesson, the student should be able to define the electromagnetic spectrum, outline the types of electromagnetic radiation, list the different wavelengths in the electromagnetic spectrum, explain ionizing radiation, explain non-ionizing radiation, and explain the biological effects of electromagnetic radiations. It's important we look at wavelength before we talk about the electromagnetic spectrum. The distance between two wave crests or trough is the wavelength. The crest is the highest point of a wave, while the lowest point of a wave is called a trough. Electromagnetic waves has electrical and magnetic properties. It causes charged particles to move up and down and can travel through solid, liquid, gases, and through vacuum, that is empty space. It travels at the speed of light, 3 times 10 raised to power 8 meters per second. Electromagnetic waves has both frequency and wavelength. We have seen that if we have a longer wavelength, we have lower frequency, as shown in figure 1. And then if we have shorter wavelength, we will have higher frequency. Don't fail to watch the video on wavelength in my YouTube channel, Ozioma Ekpete at Ozioma Ekpete 4940. We're looking at the electromagnetic spectrum. The electromagnetic spectrum is the range of all possible frequencies of electromagnetic radiations in order of increasing frequency and decreasing wavelength. Frequency we know is expressed in Hz, Hz, and refers to the number of wavelengths that pass a fixed point in 1 second. The shorter the wavelength is, the higher its frequency. And the longer the wavelength, the lower its frequency. We can look at the radio waves. From this figure, we'll see that it has longer wavelengths. The distance between each crest is far apart, so it shows longer wavelength. Looking at the radio waves, and then when you look at the gamma rays, you find out that the gamma rays has shorter wavelength. Shorter wavelength. Electromagnetic energy travels in waves and spans a broad spectrum from very long radio waves to very short gamma rays. The human eye can only detect only a small portion of this spectrum called visible light. This visible light, as we can see it as shown on this figure. A radio detects a different portion of the spectrum, and an X-ray machine uses yet another portion. All of them are just in their portions. So on the electromagnetic spectrum, we have the radio waves, the microwaves, the infrared waves, the visible light, the ultraviolet, the X-rays, and the gamma rays. We have different wavelength and frequency, and then we'll have the SI prefixes and symbols. The radio waves is a distance of 1 meter to thousands of kilometers, and it can be seen at a frequency of 3 Hz to 300 gigahertz. We have the microwave, 1 millimeter to 1 meter, 3 gigahertz to 300 gigahertz. Then we have the infrared spectrum. Infrared, 700 nanometer to 1 millimeter, 300 gigahertz to 400 terahertz. We have the visible light, 400 nanometer to 700 nanometer, and these are visible to the eyes. We have 400 terahertz to 800 terahertz. And then we have the ultraviolet, 10 to 400 nanometer. The frequency is 800 terahertz to 30 pentahertz. We have the X-ray short wavelength, 0.01 to 10 nanometer. Frequency of 30 petahertz to 30 exahertz. And then we have the gamma rays, highest frequency, the shortest wavelength, less than 0.01 nanometer. And the frequency is greater than 30 exahertz. The SI and symbols have the kilo, K, 10 raised to power 3. We have the mega, M, 10 raised to power 6. We have the giga, G, 10 raised to power 9. We have the tera, T, capital T, 10 raised to power 12. We have the penta, P, 10 raised to power 15. And we have the hexa, Hertz, 10 raised to power 18. Colors of the visible light. The colors of the visible spectrum always appear in the same order as capital R, O, Y, G, B, I, V. R stands for red. Occurs at 620 to 750 nanometers and at 400 to 480 terahertz. The second is the orange, 590 to 620 nanometer, 480 to 510 terahertz. We have the orange. The yellow, 570 to 590 nanometer and 510 to 530 terahertz. We have the green, 520 to 570 nanometer, 530 to 560 terahertz. We have the blue, 450 to 520 nanometer, 560 to 620 terahertz. We have the indigo, 420 to 450 nanometer, 620 to 660 terahertz. And then we have the violet, 400 to 420 nanometer, 660 to 720 terahertz. The visible spectrum is the only part of the electromagnetic spectrum that is visible to the human eyes. We have non-ionizing radiation with low frequency. Non-ionizing radiations are low energy radiations that cannot ionize atoms and molecules. Examples are visible light, IR, microwave radiation, and radio waves. Visible light can cause eye strain and discomfort. Infrared, microwave, radio frequency can cause heating effect leading to burns, cataract, and tissue change or tissue damage. We have the ionizing radiation with high frequency. Ionizing radiations are high radiations that can ionize atoms and molecules. Examples are gamma rays, X-rays, and UV radiations. Gamma rays, we know, can cause genetic mutations and damage to DNA. X-rays have similar effects to gamma rays, but less severe. UV radiations causes sunburn, premature aging, and skin cancer. The effect of electromagnetic radiation on living organisms depends on the duration and intensity of exposure. Some effects are beneficial, e.g. UV radiation for vitamin D production, while others are harmful. Applications of the electromagnetic spectrum. Electromagnetic spectrum is useful in communication, the radio broadcasting, mobile phones, Wi-Fi, satellite communications are the effects of electromagnetic spectrum. Useful in medicine, like in X-ray imaging, magnetic resonance imaging, laser treatment, radiation treatment for cancer. Useful for science, spectroscopy for chemical analysis, UV and X-ray observations. For food processing, the microwave ovens for cooking and sterilization, for UV light for disinfection and sterilization. It is used for environmental monitoring, radar for weather forecasting, sensing for climate change research, air and water quality monitoring. It's also useful for security, metal detectors, airport security cameras, surveillance cameras. It's also useful in consumer products, microwave ovens, infrared thermometers, UV lamps for disinfection and curing, drones and cars. It's useful for the military. They use the laser-guided missiles, night vision technology, agriculture, crop monitoring and hyperspectral imaging, remote sensing, and GPS. The uses of or applications of the electromagnetic spectrum cannot be overemphasized. It is very, very useful for humanity. Conclusion. The electromagnetic spectrum has low frequency radio waves to high energy of gamma rays with so many applications in communication, medicine to industry, scientific research, and environmental monitoring. It helps us to understand weather patterns and the behavior of matter at the atomic and subatomic levels. It plays a vital role in shaping our world and has led to numerous breakthroughs in medicine, in technology, medicine, and in understanding our universe. We have some study questions for all of us. 1. Define the electromagnetic spectrum. Outline the types of electromagnetic radiation. 2. 3. What is the difference between ionizing and non-ionizing radiations in electromagnetic spectrum? 4. What is the role of X-rays in medical imaging and how do they interact with the human body? 5. Explain 5 applications of the electromagnetic spectrum. Thank you for listening to this video to the end. Don't forget to subscribe, like, comment, and share. I also recommend that you watch the video on wavelength before coming over to this electromagnetic spectrum. It will help you. It will help you. Thank you for your time. See you in the next class.